Okay, in this video we're going to do some trig and we're going to work with triangles a bit. So you'll find early on in physics, the first few chapters, that triangles are your friend, especially right triangles, which is what we're going to focus on mostly. So we're going to do a little review of triangles. So first of all, our right triangle is defined by having a right angle, an angle of 90 degrees. And all triangles have angles. I'm going to call this one theta and this one phi. All of the angles should add up to 180 degrees. And if you think about it, a triangle, if we were to break the triangle up at this point over here and then lay this side flat and then take this side and lay it flat, it would make 180 degrees because it would be a flat line, 180 degrees. So kind of think of it that way, like you're unwrapping a triangle. Okay, so this means if all this equals 180 degrees, that my two corner angles should equal 90 when added together. Alrighty, so important thing to remember. Next we're going to look at the sides of a right triangle. We're going to call this side A, side B, and we're going to call this side C, or our hypotenuse. And this should look pretty familiar. This cool guy named Pythagoras figured this out. A squared plus B squared equals C squared. So one of our sides plus squared plus the square of our other side should equal our hypotenuse squared. I'll show you in a little bit how this relates a little bit more directly to physics and vectors and whatnot. Okay, so those are our sides and how they relate to each other. Now we're going to review a little bit of trig. So let me get my right angle and let me get my theta out here again. Alright, let's say that we have an unknown angle here. We're going to call the side that is next to the angle theta our adjacent side. Adjacent means next to. And we're going to call the side opposite our angle the opposite side. And this is still the hypotenuse. Okay, so side A, side B, side C, or I'm going to start talking about it in terms of x's and y's. This goes along our x-axis, this would be our y-axis. Okay. This is the mnemonic device I learned when learning trig functions. Okay. SOH CAH TOA. Or as I sometimes like to write it like this. And you'll see why in just a second. So okay, so the S, C, and T sign, pardon me, stand for sine, cosine, and tangent. So the sine of our angle theta is going to be equal to the magnitude of our opposite side over the magnitude of our hypotenuse. Or, let's write it as A, B, and C again. So this would be B over C. The cosine of theta is the adjacent side over the hypotenuse. or A over C. And lastly, tangent theta is the opposite side over the adjacent side. So B over A, or in terms of x's and y's, it'll be our y over our x. Rise over run. Sound familiar? It's kind of like the slope of a line. The slope of our hypotenuse, in fact. Okay. So let's apply this to vectors. So let's see. Let me find a red. Here's our vector. Our vector is this line. It goes in that direction. Add it, and it's at some angle theta. Now, two-dimensional vectors are nice because they can break down into our right triangles, where the x component is the bottom side and the y component is the vertical component. Okay, which means that the slope of our vector, this line here, is y over x. Okay, and I don't know, let's call the magnitude of our vector is 5. Okay, so, and let's say that this could be a velocity vector, so it could be 5 meters per second. It could be a force vector, which would make it 5 newtons. So let's talk about it in terms of, let's say it's meters per second for now. We're dealing with velocity at an angle. So let's say that we have to find the horizontal and the vertical components of our velocity. So it's a triangle. Alright, so our horizontal component is going to be in the x direction. Now we know that, let's say that we're given the information that our theta is equal to 30 degrees. That 3 is very messy, I'm sorry. 30 degrees. Okay, so we also know, if we remember from our trig review, that cosine is the adjacent over the hypotenuse. So I'm going to write up our SOH CAH TOA over here just to have it on hand to remember. SOH CAH TOA. SOH CAH TOA. Alright. So since this side is adjacent to the angle, we're going to use cosine. So cosine of 30 is our angle, 30 degrees, is going to be equal to x over the hypotenuse, which is the magnitude of the vector, 5 meters per second. It's a messy 5 too. Tisk tisk. Okay, and we can rewrite this to put x on one side of the equation. Cosine 30 degrees. And you'll notice that I do this automatically now. I just write components in this format. The x equals or the y equals hypotenuse times the sine, cosine, etc. of the angle. So for the vertical component, this is going to be y is equal to the hypotenuse, again, which is 5 times, this time we're going to use sine of 30, because y is opposite of 30 here. Opposite, adjacent. Okay, so that would be how I would break down a vector. For example, force vector, velocity vector, anything like that into its x and its y components. So I'm not going to solve these numbers out exactly, but whatever these come out to in meters per second will be our x and our y components. Alright, and I'm going to do a separate video on vector addition, but you will be seeing this again in it because the ability to break down these vectors into their components is essential for vector addition and subtraction. So keep a lookout for that one, and thanks for watching. If you have any comments or questions, leave me a message.